systems of linear equations in three variables. So we've spent quite a bit of time looking at systems of linear equations in two variables. We're now going to turn our attention to systems in three variables. Our objective here, we want to verify the solution of a system of linear equations in three variables. So what do we know? Well, we know what a linear system is. It is two or more linear equations working together. The linear equations are often written in the general form. However, you can also see them written in the y equals or x equals form. When dealing with three variables, they'll look like this. And I don't think I've ever seen them not be x, y's, and z's. We've introduced the z variable here. All three of these equations would be in the general form with the x before the y before the z and the constant on the right side. So graphically, kind of tough to do because when we're dealing with a linear system in three variables, we're now talking about graphing in three dimensions, which is not going to really take place with our graphing calculators or our graphing devices. We're going to need some computers and some computer software to look at something like that, but we're not going to do that. Okay, something that we're not able to do. So with three variables, we're going to be using the x-axis for the x variable, the y-axis for the y variable, and the z-axis for the z variable. And if we were to see the graph of each of these linear equations would be not a line, but a plane in three-dimensional space. It's a line in two-dimensional space. It's a plane in three-dimensional space. So, similar to linear systems in two variables, an ordered triple as opposed to an ordered pair, an ordered triple is a solution to a system of linear equations in three variables if it satisfies all three equations in the system. So we saw this with an ordered pair satisfying a system of linear equations in two variables. It had to satisfy both. Here, when we have a system with three variables, we're going to have an ordered triple, and it has to satisfy all three in order to be a solution to the particular system. Let's take a look at an example, not particularly complicated. Example 1, show that the ordered triple, -1, 2, -2, so this is your x, this is your y, and this is your z, is the solution of this system. Three equations and three unknowns. I'm going to label them as I've done in the past. I'm going to label them equations 1, 2, and 3 so that I can refer back to them. So the ordered triple is the solution to the system if the ordered triple is the solution to all three equations. Well, let's go. Equation number 1 is x plus 2y minus 3z. You'll note I put a line in my z's, otherwise my z's can look like 5s, and I want to differentiate a z from a 5. Equals 9. The ordered triple is x -1, y 2, z -2. So we'll put -1 in for x, we'll put 2 in for y, we'll put -2 in for z, and this is a question. Does this ordered triple make this equation true? Well, this is -1 plus 4, which is 3, and 3 plus 6 is 9. So for equation number 1, the ordered triple makes it true. Let's do equation number 2. Again, we've got to satisfy all three equations. So equation 2 is 2x minus y plus 2z is equal to -8. Let's check our ordered triple in equation number 2. 2 times -1 minus 2 plus 2 times -2. Does this equal -8? Well, here is -2. -2 minus 2 is -4. -4 plus -4 is -8. Can do that one mentally pretty well. So we're 2 for 2. Our ordered triple satisfies 2 of them, but it has to satisfy all 3. So let's finish with the third one. And our third equation is opposite of x plus 3y minus 4z equals 15. Okay, right here's our third equation. Again, we want to check this ordered triple solution. So the opposite of -1. Notice how handy using parentheses. I don't lose negatives very well this way. Plus 3 times 2 minus 4 times -2. Does this equal 15? That's a question. 1 plus 6 is 7. Plus 8 is 15. So, yep. Turns out our ordered triple is a solution to all 3 equations. Let's note that down here. The ordered triple, and it's -1, 2, -2, representing x, y, and z, satisfies all three equations. We just checked the math on all 3 of them, and it worked for all 3. That tells us it is a solution of the system. So there you have it. Looks remarkably familiar to what we did with linear systems and 2 unknowns. Just take your time, check the ordered triple with all 3 equations. If it works for all 3, it's a solution. If it doesn't work for even just one of them, it is not a solution.